Katie, did you know that the brain is made up of over 100 million cells?
I didn't know that, no, Ben.
And did you know that the eye blinks over 6,000 million times a year?
You're so interesting.
But even better than that, the common cold virus is a staggering 0.00007 metres wide.
My goodness me, you probably know how fast grass grows, don't you?
Yeah, too fast, I have to cut it. Now, you might have realised that today's show is about big numbers and small numbers. Very big numbers, very small numbers, how you write them down and how you do maths with them.
Which is why we're at this sweet factory in York. Chocolate production involves some mind-boggling numbers, so chocoholics, get ready to drool.
Up to 270 million polos every week.
They knock out around 3,700,000 Kit Kats a day.
The chocolate disc at the centre of a Smartie weighs just 0.0005 kilograms.
Talking about very big and very small numbers is bad enough, but having to write them down with all those zeros, that's a right pain. Fortunately, there is a very neat and mathematical shorthand. It's called standard form, and it works like this.
Let's say that every day a sweet factory produces 55 million chocolates. In standard form, this is written as 5.5 times 10 to the power of 7. But what does the 10 to the power of 7 mean?
10 to the power of 7 is the same as 10 times 10 times 10 times 10 times 10 times 10 times 10.
So 5.5 times 10 to the power of 7 means 5.5 multiplied by 10 7 times. Each time you multiply by 10, the figures move one place value to the left of the decimal point, which gets us back to 55 million.
A number in standard form always has these parts: a number, a multiplication sign, and a power of 10. This number is always greater than or equal to 1, but less than 10. The power of 10 tells you about the size of the number. For large numbers, this power is always a positive value, and for very small numbers, it's always a negative value.
Take 0.0000055. Written in standard form, it's 5.5 times 10 to the power of negative 7. A power of negative 7 tells us to divide 5.5 by 10 7 times. Each time you divide by 10, the figures move one place value to the right of the point, which gets us back to 0.0000055.
So what about those numbers we saw earlier?
270 million becomes 2.7 times 10 to the power of 8.
3,700,000 becomes 3.7 times 10 to the power of 6.
0.0005 becomes 5 times 10 to the power of negative 4. See if you can work this one out.
There are 21,000 million Smarties produced each year. What is that in standard form notation?
Is it 21 times 10 to the power of 9 or 2.1 times 10 to the power of 10?
There are three main ingredients in chocolate: sugar, milk powder and cocoa powder. Mix them all together, add a little bit of magic, and you're in chocolate heaven. But there are also other substances in chocolate too, in tiny amounts. For example, there's 0.00007 grams of vitamin E in 1 gram of milk chocolate. Now, in maths exams, you're often asked to multiply numbers that are in standard form. So you might be asked, for example, if there's 0.00007 grams of vitamin E in 1 gram of milk chocolate, how much is there in 1 kilogram? Now, 1 kilogram is 1,000 grams, so you need to multiply that by 1,000. So 0.000007 would be 7 times 10 to the power of negative 6. And then you need to multiply that by 1 times 10 to the power of 3. First, you need to rearrange the sum, grouping the ordinary numbers together and the powers of 10 together. Next, multiply the front figures to get 7. And then deal with the powers of 10. This is where you need to take care. When multiplying powers, you add them. In this case, that means adding negative 6 and 3, which gives a final answer of 7 times 10 to the power of negative 3 grams.
Katie, did you know that hair grows at 0.0...
Ben, I don't want to know. I don't want to know. We've got to leave now, but
Right.
They weigh you when you go, so I hope you haven't taken anything.
They weigh you?
Yeah.
No
yeah.
one told me that...
Yeah, so... have you
Put these back then. I only took a couple, I didn't
You've
think
got
they'd
to put
mind.
them back. I can't
But they've got
believe it. When
loads.
did you get them? When did you
I
get them?
don't think they'd mind, they've got loads.
No, we've got to give these back.
Astronomers use numbers in standard form all the time. I'm here at the University of Manchester's Jodrell Bank in Cheshire, where astronomers probe the depths of space with the latest technologies. These satellite dishes that they have here at Jodrell Bank you can think of as really powerful ears that pick up signals from spacecraft and stars that are millions of miles away. In fact, the collection of dishes here are amongst the most powerful in the world. One daily task is to track signals from the Pioneer 10 space probe that was launched on the 2nd of March in 1972. It was the first human-made object to take close-up images of Jupiter and to leave the solar system. In 1983, it travelled beyond Pluto. Today, it's more than 11,000 million kilometres away. Distances like that can be really quite tricky to get your head round, so here's a scale model. Imagine that I'm the Sun. Then the Earth would be 1 metre away. At this scale, Pluto would be 50 metres away. And Pioneer 10 would be 65 metres away. But the galaxy that Karen Wills has been studying is 10,000 million times further away than that.
I was wondering, do you think we could get Merlin to have a look at this region round here, the star formation region?
Karen, why are you so interested in studying a galaxy that's so unimaginably far away?
Well, this galaxy is one of the nearest examples of a starburst galaxy. And what this means is it's like a star factory producing stars much more rapidly than normal galaxies produce stars. Now, this is actually quite unusual, but in the early universe, just after the Big Bang, this is how all galaxies were. And so in understanding this nearby galaxy, we're trying to understand the early universe.
So tell me, how far away is this galaxy?
Well, the distance of this galaxy from Earth in metres is actually 9 with 22 zeros after it.
No way.
Now, I don't want to be writing down all those zeros, so that's why standard form is really essential for astronomers.
Right, it's time for some maths. Now, let's say I wanted to work out how long it would take light to come from Karen's galaxy to reach the Earth, which is a sort of standard question you're going to be faced with in your exams. If you want to do that, we're going to have to use this equation here, which is time equals distance divided by speed. Now, fortunately, Karen's going to help us. She's going to be Carol Boardman. It's my Richard Whiteley. I know you're excited. Karen, how far away is your galaxy?
It's 9 times 10 to the power of 22 metres.
Great, and that's divided by speed, which is the speed of light, which equals...
It's 3 times 10 to the power of 8 metres per second.
Fantastic. So that means that the time equals 9 times 10 to the power of 22 divided by 3 times 10 to the power of 8. Now this is how you divide in standard form. First, rearrange the sum, grouping the ordinary numbers together and the powers of 10 together. Next, divide the front figures. 9 divided by 3 is 3. And then deal with the powers of 10. Again, this is where you need to be careful. When dividing powers, you subtract them, which in this case is 22 minus 8, to give a final answer of 3 times 10 to the power of 14 seconds. So that's 3 times 10 to the power of 14 seconds. But what does that mean?
Well, that means the light left the galaxy 10 million years ago. In other words, before humans were even walking on the Earth.
What, even before Richard Whiteley?
Even Richard Whiteley.
God, life before Richard Whiteley, eh? Who'd have thought it? It's Tick or Trash, that part of the programme where Katie and I actually have to do some maths for real. We're both going to do the same question, but only one of us does it correctly.
That's right, the other makes a deliberate mistake, which you have to spot. You decide, do you tick it or trash it?
Now, this week's teaser is about the common cold.
The virus that causes the common cold is incredibly tiny. It's just 5 times 10 to the power of -7 metres long. The question is, placed end to end, how long would a chain of 3 times 10 to the power of 11 viruses be? Giving your answer in standard form, pens at the ready, go.
Here's the question again. If the common cold virus is 5 times 10 to the power of -7 metres long, placed end to end, how long would a chain of 3 times 10 to the power of 11 viruses be in standard form? The calculation involves multiplying two numbers in standard form. 3 times 10 to the power of 11 multiplied by 5 times 10 to the power of -7. First of all, I need to rearrange the sum, putting the number parts together and the powers of 10 together. Next, I multiply the 3 and the 5 to get 15, and then I multiply the powers of 10. To do that, I added the power numbers, that's 11, plus -7, which is 4. So my answer is 15 times 10 to the power of 4. Now this number here is greater than 10, so to put it into standard form, I need to change it to 1.5 times 10 multiplied by 10 to the power of 4. So that means my final answer is 1.5 times 10 to the power of 5 metres.
Like Ben, I started by rearranging the sum, grouping the numbers and the powers of 10 together. 3 multiplied by 5 is 15. Then I multiplied the powers of 10. To do that, I multiplied 11 by -7, which is -77. So in standard form, the answer is a length of 15 times 10 to the power of -77 metres.
So, which working out should you tick and which should you trash?
Was Ben right to add the power numbers?
Or was Katie right to multiply the power numbers?
OK, the game's up. My working out should be trashed. My first mistake was to multiply the powers of 10 together to give -77 instead of adding them together to give 4. It's a common mistake, so make sure you don't get caught out. And remember, when you're multiplying powers of 10 together, the rule is to add the powers.
And Katie's second mistake was not to give her answer in standard form. If I'd left my answer like this, as 15 times 10 to the power of 4, I'd have lost marks. I've done my working out right, but it isn't in standard form because the first number here is more than 10. The correct answer is 1.5 times 10 to the power of 5 metres. Remember to watch out for those powers of 10 when doing calculations with standard form.
When multiplying standard form numbers, always multiply the front numbers, but take care to add the powers of 10.
When dividing standard form numbers, always divide the front numbers, but take care to subtract the powers of 10.